is Trisha with Insectopia, and we are here sketching a whole new insect today. On this past Monday, I took 3 hours and did an entire collection tour, so you got to see everything that is currently in my collection and labeled. That was a great, fun day. We are going to be, so I was chatting in the box with our friend Susan, and she mentioned maybe a Dobsonfly. Well, the funny thing is, I was actually sitting here already with a Dobsonfly underneath the microscope, thinking that this was going to be the one that we were doing today. But I wanted to leave it up to you, and I just laughed really hard when you mentioned, let's do a Dobsonfly, because I'm like, aha, you are reading my mind. So, yes, and then you mentioned the grasshoppers and the thistledown velvet ant, those types of things. And admittedly, I would really, really love to do the thistledown velvet ant one day. I had mentioned that I wanted to do it, and Marley was there that day, and he was like, oh no, we can't draw any white bugs. And so I hadn't even suggested it since. But I definitely laughed about it, because I guess if you were drawing the thistledown velvet ant, it would almost be better to have a black piece of paper and draw it with white ink. And that could be a fun little experiment too, so maybe I'll play around with that. That could be fun. Susan says, great minds think alike. I would have to agree. Now, one of the rules for the difference between Dobsonflies and fish flies, at least one of the rules that I was always told, and actually I taught about Dobsonflies today to my students, so here we are. Alright, so one difference between Dobsonflies and fish flies, because actually I'm going to go to the older kids page. There we go. The difference between Dobsonflies and fish flies is that, well, they're both in this order Megaloptera, right? So that's a similarity. And I believe they're even both in the same family. I believe they're both Corydalids, but let me look that up really quick. Yeah. So Dobsonflies and fish flies are not only in the same order, Megaloptera, they're in the same family, Corydalidae. Alright? And so they're both here. But then if we want to separate the difference between a Dobsonfly and a fish fly, the way that I was always told is that Dobsonflies have these long filiform antennae, and then fish flies have feathery antennae. And if you look at most fish flies, that is the case. I believe there is actually a spring fish fly that has filiform antennae that breaks the rule that I learned about recently that I was all mad about. Because once something breaks the rule, then it's not a rule anymore, and then I have to figure out another way to describe them. But I do believe that this friend that we are looking at here with the super extended mandibles and the filiform antenna are Dobsonflies. Alright. Very cool. And if I was a lady, I would be impressed by his mandibles too. Actually, if I was a Dobsonfly, I'd be impressed with his mandibles too, Susan. Aww. Well, the funny thing about, well, that's the thing. Marley's likes stabby things. He likes hymenopterans, bees and wasps, and I thought he liked ants. But I guess he just doesn't like cetose, fun, fluffy insects. Alright, I want to go ahead and switch over to this table camera for a second and show our beautiful Dobsonfly in all of its glory. Maybe I will even get it a little bit closer to the camera. No, that's too close. That's fine. Alright, we're going to put a ruler on it, and we're going to see what the length is. Should I measure it from the front of the head, or should I measure it from the front of the mandibles? I guess I'm going to measure our Dobsonfly from the front of the head. And then if you want, I can also measure the mandibles. Let's see. I would say the length of our Dobson... Oh, no! Give me a moment. I just knocked one of our Dobsonflies' antenna off with my ruler. I looked up for 1 second and my hand shook. So, our Dobsonfly, I'm just going to give you the number that I was thinking, is about 5.5 centimeters long. We're going to be gluing its antenna back on under the microscope together. Front of the head to the end of the abdomen. The abdomen is a little shorter than that. Let me give you a second. From the front of the head to the end of the abdomen, our specimen is about 4.8 centimeters. We're going to fix my specimen right now. Aw, that was before its antenna broke off. So it looks like it broke right at the flagellum. The scape and the pedicel are still connected to the head, and so it was the flagellum that broke off of the pedicel. And doing this on a microscope is a lot easier than doing this off of a microscope, because then you get all of the fine details. So just hang out with me for a minute while I do this. I'm probably not going to chat too much while I'm gluing it back on, just because I need to focus. I think this is my only Dobsonfly friend. Don't you want your antenna back? Here. Okay. Sorry about that little bit of drama. Really gotta watch out for those specimens there. We're gonna be really gentle with it for a little bit of time to make sure that that antenna doesn't get bumped while it's drying. And then when it's dry, all the way dry, I might come back under my microscope and add just a little bit of glue around the edge where it connected. But I think the shot was pretty good. The antenna is right there on the end of the pedestal. I'm pretty happy with that. You're not going to get too much better when you're gluing a specimen back together. What does this antenna think it is? A creamfly's leg? Right? But we got it all figured out. Our specimen is back together. Everything is a-okay. We are looking at a corydalid, and I was actually just about to see if I could come up with an identification for you. This specimen was collected in Oak Creek, Arizona. And so I'm pretty familiar with the Dobsonflies on the East Coast because I believe there's only one species. But I want to look up the western Dobsonfly, Dobsonflies in the west, to see how many species there are. Looks like there's just, well, 2 common ones in iNaturalist. That looks right. Corydallis texanus. All right, so I'm going to give you the my best guess. My best guess identification. I haven't gone through and done I haven't gone through and keyed it out or even gone through a whole number of pictures, but I went through a little bit, and I think what we are looking at based on the range is Corydallis texanus. And that is the western Dobsonfly. This individual was collected in Arizona in 2009. So it's one of my older specimens. And if I collected it in 2009? Huh. Okay. I thought that was 2010, but I I must have gotten my numbers mixed up. That's fine. Corydallis texanus. All right, we have Corydallis texanus that we're looking at here. I am going to pull our specimen off the microscope and move it so that it is right about here so that we can look at its body in its entirety and maybe be able to keep the measurements very similar. You can see he has these ginormous mandibles, right? I think that those are pretty nifty. And it's funny because adult Dobsonflies don't eat. They only eat when they are nymphs, when they're babies. All right, so to start us off with a light outline of a sketch. Man, I'm going to turn off this autofocus. There we go. Misty, be gentle. Alright, so our autofocus is turned off, so now hopefully everything will be better. We have those ginormous mandibles that actually look like they are longer than the head. My cat is jumping around in the ceiling. I'm just making sure she's all right. She seems to be pretty good at it. So, Misty, the youngest one, she is on an adventure. All right, let's see. I'm just gonna start off with the back of the head and give myself this nice square here, and it looks like that's gonna be way too big because, the wings are so long, sometimes that messes with me. You need to start the head pretty small so that you have enough space on your paper for those wings. Alright, so I'm going to start off with a shape like this, and I'm going to center it better. Alright, so I've got this very kind of square base of the head here, and instead of taking the time to worry about where the antenna and the eyes are going to come up, I'm just giving myself this basic shape, because you know we're going to be zooming in on our microscope. So if you just go ahead and pull it all the way through so that you don't worry about the eyes, but then you're going to want to give yourself like the top of a house, like a point up here. Because then you can take these edges here and expand them out to kind of make those mandibles. And our mandibles, admittedly, I kind of made these two curved. They're going to go straight for a while, and then they curve at the end. So you see our mandibles go pretty much straight, parallel, and then at the very end they curve together. And those mandibles are longer than the head. I like that, starting with a center line and then marking proportions. I feel like I did that with the walking stick. Made the entire line and then marked off where each of the legs were going to come off. That was actually really helpful. I'm going to have to try and do it for more insects. So here you'd say the wings are 3/4 of the total length, with the pronotum head and mandibles making up the last quarter. Yeah, I would say that's pretty close. So if you knew the length of your line, you could then just divide that 3/4 up. Let's see. If I add my pronotum, which is that kind of thinner neck region, and it is about the length of the head, then I could multiply it out just like you're saying. So if I took the measurement of this and I said, oh, that's 5.5, then I would need to multiply 5.5 times 3 for my wings, which would be 5, 10, 15 plus 1.5, 16.5. Do I have 16.5? I do not. I have 14.5. You know what? That's just going to have to do. I'm going to make the wings the rest of this paper, and that's going to be crazy because our friend here is super duper long. All right, so we're going to give ourselves shoulders just a little bit. The wings are not too wide off of the pronotum, but our friend here does have some shoulders. I can tell you from experience that he's got this region here in between his wings. Now, for any other insect, I would call this a scutellum, but with corydalis, with Dobsonflies, I'm not sure if we still call it a scutellum. But we can take, from experience, I know that it's this specimen's right wing that is over the top of the left wing. So if you already know the length of your specimen's wings, mine are going to go all the way to the end of my paper here. Does that make sense? I feel like it's too big. Give me a moment. I have to fix my lines here. I would say it's more like 3 than... No, you're probably about right. My wings here, they don't want to be that long. And generally, the wings do separate like that at the end. Hi, Avia. No problem. We are sketching a Dobsonfly, and we're pretty much just starting with our light outline. So, feel free to join us. The length of our specimen from the front of the head to the back of the abdomen, which is right about here where the wings cross, is about 4.8 centimeters. Howdy, AC! Those are totally some sexy mandibles. Yeah, they are. Thanks, Avea. The green hair is just a reflection off of the green screen. I try and play with the lighting to make sure that, I'm going clear, to make sure it doesn't do that. Hi, Caitlin! So, today you thought it was Halloween related. That's okay. Let's see, we've got our head, our pronotum. Something is wrong in this region, but I'll have to fix that when we get there. I think that maybe the reason is that I need my head and my pronotum to be wider. But we will play with that when we zoom in. That gives me a basic idea, and we'll be playing with those as we move along. You know what's really cool? I wanted to share this with you, ladies and gentlemen. I wanted to try to minimize our scammers because we've been getting hit a little bit more recently. And so I made the chat box so that only you subscribers could chat with me. So if the scammers wanna scam our chat, they have to subscribe first. Alright, so let's check out that head. I love these these mandibles. And I'm trying to get my sketch just a little bit taller for you guys. Gotta pick a better book. This book. That'll be tall enough. Yeah. Alright, so the back of our... Ooh, we're fancy. Yeah, exactly. I do love the texture on this guy, and we can zoom in even further to really check out some of this texture. If we're looking at, let's say, right here. Oh, not that far, friend. Check that out. Oh, Avea, happy numbers in nature. I love this region right... I love this region of the head right here and here. It almost looks like somebody was like chiseling out of its head a little bit. If you go here all the way up to the point, there is actually an ocelli, a simple eye, that's facing forward at the end of that hill right there. So we have an ocelli here, an ocelli here, and then one going forward. So there is a triangle of those happening here. We do have two compound eyes over here to the sides. They expand away from the basic level of the head. And if we want to scooch our specimen up a little bit, we can look at these mandibles here. Now, Dobsonflies are unique in that their immature stage is the only feeding stage. The adults, where they have mandibles and they have mouth holes and they have labial palps and they have labrums, they don't actually eat. At least most of them. I'm sure there's one or two of them that break the rule, but Dobsonflies generally don't eat after they become adults because their number one goal is to mate and lay eggs and then unfortunately die because they don't live for very long. At least it's not no numbers November. Oh, I guess that's true. And I like that the mandibles, they have those little rings around the end of them, around the median, I guess. I like the rings. Alright, we're going to zoom out again so that we can see at least the entire head for sketching purposes. But I'm glad we got to zoom in and look around. And you can barely even tell that I just glued that antenna back on. Alright, so I think what I'm going to do is really widen this head here. I think what I did before is that it's just a little bit too narrow for the rest of my body, or at least for the length of it. So we're going to kind of widen this head out, maybe like this. That's already looking better. Alright, so I'm going to widen this head out, and it looks like it's almost 90 degrees, but these are rounded edges back here. So go ahead and make sure the back of your head is nice and round. Then when you get up to about this point, this is where the eyes are. And so instead of just continuing through, you can add our eyes here by giving these little backwards parentheses and then filling out the circles. But what you do when you fill out that circle, you want to make sure that you go past this line so that the eye looks like it's kind of bulging away from the head. Alright, so then we have those eyes. Now, Right about here in the center of our head, this is where we have that spine, that detailing. And actually that's not very centered, huh? That's better. All right, so right about here in the center, we have that kind of longer spine that's very narrow, and then it goes all the way up to in between the compound eyes and ends with an ocelli that goes forward that you can only see almost like a little half moon of. You can't really see the entire eye, the one that goes forward, but you can see this one and this one. And instead of making them perfect circles, I'm making them kind of little D shapes so that you can see that they're kind of connected to this hill right here if you make them all flat. If I was going to zoom in on that point, it looks a little bit... It looks a little bit like this, where you've got three eyes and they are centrally located, and if you actually followed the lines of these D's, in theory, they make a triangle that points down. Very, very small, right here. Okay. Now, we want to make sure we've got our antennal sockets here. Our antennal sockets are closer to the compound eyes than the ocelli, so we're going to add them right in this region. Not touching the eye, just closer to the eye. There we go. All right, so we've got antennal sockets. We're going to be sketching a scape, a pedicel, and then the flagellum. And the scape is that segment that's super, super well connected to the antennal socket. The pedicel is holds on to the scape, but also creates a lot of the flexibility in the movement. And then going further, it's the flagellum. Now, this antenna on the left actually broke right after the pedicel, right before the flagellum, and I think that's because there is the most movement right there in the antenna, so if it was going to break at any point, it's going to be breaking at the point where there's the most movement. That makes sense to me. Alright, so let's see, our scape. I'm going to be erasing, I have to erase some of these eye lines because I want to make sure my antennae are going over them. So I've got my scape, that's my first segment, and then I have my pedicel, it's the second round one. And then you've got nice long antenna. These antennae, let's see, are approximately... the length of the entire mandible's head and pronotum combined is what it looks like to me. If I was to take those antennae and stretch them out, so what you could do is kind of put your fingers over that piece and then try and figure out how long your antennae are going to be. For me, it's going to look something like this, likely. Coming out from the head, going past the shoulders, about a third of the way down the wings. I think that's about right for me. And I'm just going to make these antennae long and straight, and then as it gets closer to the end, it gets narrower and narrower until it comes to a fine point. Now I can come back in and kind of harden those, darken those eyes again. So he's got eyes. Now, you can see there are many segments in these antennae. Really, if you were doing numbers in November, I guess you could count them. But we could just say there's a whole lot. So each each one of those segments, you can see that there is a little bit of like, they are almost square all the way to the end. And so instead of just coming in and adding all of the cross sections and making them look smooth, what I'm going to do is I'm going to estimate the approximate size of those antennal segments. And I'm just going to make along this, along these two lines, I'm going to start and just make these little squares. And if I make individual squares rather than, just lining it off, you're more likely to have a little bit of personality on each one of these segments. And because we are following the lines, we know that our segments are narrowing at a proper rate, and we know that they're narrowing at a proper rate, and it'll look nice. And we have lines to follow. Man, all good things. I believe when it gets closer to the end, these segments get shorter and shorter. So as yours closes in on the end, you can make them shorter and shorter. The fun thing is that as these segments are getting shorter and shorter, they're also getting darker and darker in real life. You can see how the antenna gets really dark at the end. And if you're using ink and it's getting closer together, those areas are also going to look darker, which is kind of cool. So there you go. We've got our first antenna. The second antenna, what I'm going to do is I'm just going to kind of start it off, but then I'm not going to finish it, I don't think. Let's see what happens. Ah, that was too wide. That's fine for now. At the end of our sketch, I might come back up and divide these antennae. Alrighty, so we've got those antennae figured out. We have the compound eyes situated, the base of the head. So we are going to go ahead and look at up here at the front region. Maybe just looking at mostly in front of the head and where these mandibles are starting. Cool. Alright, so starting from in front of our eyes, you can see that the mandibles start pretty much right in front of the eyes. Right after that, the base of the compound eyes. So my mandibles are just a little bit off center, so I have to erase them to move them over a little bit. But if you look at the base of your eyes, you want to go up just a little bit. Alright. And then you're going to be cutting over. Not at that angle. Up. Yeah, I mean, it is kind of that angle. Alright, so you want these lines to come angled in like this, but with a concave angle. So you can see, I don't know how much closer I can get. There we go. So this section right here, that's where the mandibles are going to be connected to. So we have those regions here that come up and in. And then from here, we want to bring it up to almost like a plateau. Now that plateau is actually right before the labrum or right before the upper lip. You can see that right here. This is the plateau I'm talking about. It's darker here. You can almost see that there's this little square right about there and a little square right about there. Those are the kind of the edges. And that's where we would consider kind of like the front of the head ending and then the mouth parts beginning. Because after this point here, up front, that's the labrum or the upper lip. So we've got kind of this fun head shape happening, and I want to make sure our mandibles get in there. So connect them right here where we were talking about our mandibles connecting. And these are going to go up straight for a time. And then they're going to curve towards one another. And I'm just going to go ahead and erase some of those words because I want to make sure that these are unique and nice. So let's see. They go up and we start curving. And it looks like if we wanted to draw it hyper-realistic with this specimen, looks like the right mandible is just a little bit in front of the left one. I'm not sure if this specimen ever met in the middle or if they've always been a little off-center. So I'm going to be sketching them a little bit off-center. So let's see. The right one is on top. I'm going to go something like that. And I might, yeah. All right, now this one is coming in. And then we do have a number of smaller spines in here that we're going to be able to also add to our mandibles. Now, because Dobsonflies don't eat, these male mandibles are mostly for impressing the ladies, fighting over ladies, and fighting over territory. They're never really going to be fighting over food because they don't really eat. So it's not a resource that they're worried about. But they are worried about location. They want to be able to lay their eggs in prime spots. Now, their babies are called Hellgrammites, spelled Hellgrammite. They are a predatory aquatic insect. And they are crazy looking. They're super awesome. So if you've never seen a Hellgrammite, go ahead and look it up now. I don't have my own personal picture of a Hellgrammite saved on my computer right now. And I don't want to share anybody else's without permission. So, if you go and find one, just let me know what you think of them. They are pretty impressive naiads or nymphs, aquatic nymphs. In pictures of Dobsonflies, they never seem to be even. And that's what I'm picturing and remembering, which is why I really didn't want to even out those mandibles, because in my experience, that's what they look like. It's like their teeth never actually match after they get so big. Now, I did want to go ahead and show you, oopsies, don't go that far, friend. I did want to zoom in and show us the labrum here so that we can get a nice sketch of it. It's this piece right here. This piece here, that's the labrum. It comes up and it arches out a little bit before it comes back down. These are palps. I'm not sure if they're maxillary or labial. Let's get it going. So right up here in the front, this is pretty small. It comes up, goes out, and comes back in. Alright, you got a little upper lip there. And then you've got your labial palps. You know, they're small, but they're up there and they exist. And they wanted to be drawn. Some more palps below the labrum. Yes, right here. Okay, so these ones up here, those ones would be the maxillary palps. They're connected to the maxilla. But if we zoom down, that is a labial palp. It's connected to the bottom lip, which we call the labium, which is why these are the labial palps. So yes, Susan, thank you for pointing that little one down here out. So now there is an equivalent on the other side too, where the labium should have 2 palps, one on each side. Man. Okay. Oh yeah, I was moving this. Let's look at our pronotum. I love that I can use the word pronotum with you guys, and most everyone knows what I mean by that body part. I generally don't feel like I have to explain it. It's the first segment of the thorax. Now, I loved the texturing and stuff on the head. The pronotum has a very different texture. Rather than looking flaky, this one looks almost bark-like, but I love the designs in the pronotum, so I'm going to just zoom it out a little bit so we can see its comparison with the width of the head, but let's go ahead and get our pronotum sketched. So coming from the back of the head, the pronotum is going to come in probably right around there. Oh man, it's going to look so good. So, the head does come angled this way, but our pronotum angles up, and the pronotum is on top. So what I'm going to do, actually, is I'm going to erase the back side of my head between where I want my pronotum to be, and I'm just going to arch it slightly up so that it's obvious that the pronotum is on top. Yeah. Okay. All right, now we've got our pronotum coming down. And then once it gets to the very end, it gets a little bit wider, but not a whole lot. And then it arches back up towards it, up in the center. So let's see. Aha! And I may or may not be happy with that. I'm gonna zoom out really quick. I want to see the length of the pronotum because I think mine may not have been long enough. Yeah, look at how pretty that is. Very good. All right. I'm going to make my pronotum just a little bit longer. More like this. That's better. You love its neck tattoos, too. Yeah. Yep. I would have to agree. I mean, what other bug has neck tattoos like this? I like that nice yellow squiggle on the left. Oh, you're totally right. I like it too. Alright, so let's get some, I'm going to get some of these designs on here. So that center triangle maybe looks like it's kind of fun, and it reaches a little less than halfway to the top. Then we have 1, 2, 3 arches. Maybe it's just not, maybe it's too long now. Alright, we're going to shorten this up a little bit. Okay. And then you have 1, 2, 3. Let's see. Man, those tattoos are a little bit more difficult on my small guy. I feel like at this point it's getting very, very fine detail-esque. Let's see. And I would definitely say if this was, if these fine details are something that you're interested in sketching, I would say do it, because the likelihood is these characteristics of this design on the pronotum probably will help you at least start identifying the specimen. These textures in the pronotum are generally the same throughout. They're not going to vary too horribly much. Another thing that people look at when they're talking about fish flies versus Dobsonflies is when we move back to the wings, a lot of Dobsonflies have these white spots in the cells of the wings. So you can see all these little white spots. Those white spots are generally even more vibrant when they are alive, but you can still see them on specimens. All of those little kind of speckles, those white spots, those are going to be helpful in identifying Dobsonfly versus fish fly. Especially if the antenna trick isn't working. Now, the wings are more than half of this specimen, like Susan had mentioned earlier. So, we are going to take just a little bit of time on the wings. I don't want to spend a whole lot of time sketching every wing venation, but I can show you a little bit about which ones are important and which ones I'm going to choose to sketch. And then you can go with however you would like. Keep in mind, if you did want to go ahead and sketch every single vein, I'm not going to stop you. And there is a pause button on the screen, so if I'm moving a little too fast for you to get all of your wing venations done, you can always pause me if you want. All right. So let's see. We are continuing on past our pronotum. A lot of times we would consider this next section here, this little triangle that's pointing down, we would consider it a scutellum. Admittedly, I'm not sure if they're called scutellums in Dobsonflies. I would think that they are, but it's possible that they don't call it that because it almost looks like there's more than one segment in there. So, we're just gonna not label it. Alrighty. But we can take, so that arch that you have from the edge of your pronotum, that's going to be your starting point for your scutellum-like segment in between the wings. Scutellum-esque. Alright, so you've got that arch arch figured out, you want to bring it a little bit past the edge of the pronotum so that at least you got it there. And then you're going to bring it in towards the center, just like our triangle here. And you can round off any and all of the edges. You know, we don't have any super sharp edges in this region. So as long as your arch is symmetrical and your V is symmetrical, that is what matters. Something like that. All right. Now, our wings, the front wings are connected to the first segment, the pronotum. The hind wings are connected to the middle segment. And so our first pair of wings are connected way up here, and then they kind of wrap around like this. I want to zoom in on the base of these wings just so that I can get a little bit more of an idea as to what they look like. I'll admit I'm not super comfortable sketching Dobsonflies. I haven't sketched very many of them in the past, and so I like to, when I'm first sketching a lot of these guys, I really like to kind of take a closer look at some of the micro stuff in here. Let's check that out. Okay. And we know that the right wing is going to be going over top. I like that X in the center of its scutellum-like segment. I like this. Let's see. It looks like a little rounded X. Alright. Now, these look like the wing connects and then folds down, and that's what's going to be giving our Dobsonfly these shoulder-like features. It's not because he's got shoulders, but it's just about how his wings fold, it looks like. And so his wings come out like this, and then they fold in. Cool. Oh, Portia, thank you. I super appreciate that. It's like Art Nouveau stained glass. Ooh, fancy. All right, we have our scutellum taken care of. I'm going to be pulling our specimen over here because I did not get the ideal outline of my wings when we were doing our first sketch. And now that I've got so much of my Dobsonfly figured out from the front, I really want to make sure that these wings are just as impressive as the front of its body. So let's see about what I can do to fix this. So with our Dobsonfly, the different thing is that these wings are not flat. They're not sitting like this. The wings do curve around the body. And so that's one thing that I think was throwing off the size of my wings. But if I start right around here and I move down like this, let's see. Get rid of some of these lines that I don't need anymore. You know what? This is looking a lot better already. That's all I needed. Alright, so I'm going to go ahead and take my sketch off of its pedestal so you can see as far away as I can. Perfect. And I'm pretty happy with the length of my wings here. I was thinking I might want to be longer, but we're pretty close. Alright. Let's get to it. I'm going to go ahead and darken the outline of my wings here. So something that I am considering Let me get these wings darkened first, and then... I have found that it is a talent being able to talk and sketch at the same time, or like talk and write at the same time. And today, or a couple days ago, when I was doing a field trip for a larger group, I was breaking the group down into some subgroups to play this game. And I was talking and teaching while counting in my head how many students I had so that I could divide the groups evenly. And I think that live streaming has helped me be able to not only sketch and talk and teach and talk, but count numbers and teach at the same time. Which is awesome. It made me happy. All right, check out those wings. The wings do not match evenly, and in my experience, Dobsonfly wings don't. In fact, I'm going to even fix these a little bit because I want to make sure that the wing tips, let's see, if this is the center, our wings meet in this, our wings kind of break away in the center and then come down to their own unique points that are even off of center. You see that? So I want to make sure we get that in here somehow. I think that's better. I think my next real issue is that I think that this wing just got a little bit too big. It arched too far over the center. I think that the wing stays closer to the center line, more like this. I am pretty happy with that. So we are going to be putting our insect back underneath the microscope. Getting some wingmination taken care of. This bug is reminding me of dates. I don't know if I really understand that. What part of the Dobsonfly reminds you of a date? Just because the veins look textured? Like, wrinkled like a date is? Is that... What do the hind wings look like? Are there hind wings? Yes, there are hind wings on our specimen. Because our specimen, where it's called a Dobsonfly, is not a true fly, right? When we look at the word Dobsonfly, it's only one word, and because the word fly is in the word, that means it's not a true fly. If we had separated it and there was a space in between Dobson and fly, that means that it would be a true fly and that it would only have two wings. So yes, they have hind wings. Now, the hind wings are not going to be super visible. The hind wings are not visible from the top. And even if I... Oh, I can show you this. I'd love to talk to you more about teaching kiddos to draw. Yeah, so If you have any questions, you can just go ahead and ask them. I love teaching the kiddos to sketch. Sometimes when I'm doing like high school level art classes, I will actually start our scientific illustrations not on blank paper, but on graphing paper, and I will give them examples of things that I have sketched. April, yes, I am blowing your mind. Double imposter, yes. So a cranefly is a dipteran, but a snakefly is not diptera. Exactly! Yes, exactly. And you can do the same thing, like a butterfly is not a true fly, and neither is a dragonfly. But then you've got, like, bugs do the same thing that flies do. So if you see the word ladybug, a ladybug is not a true bug. It's actually a beetle. So the better common name for ladybugs is the ladybird beetle. And there are two words in that. A plant bug is a true bug, but a ladybug is a beetle. Exactly! You are reading my mind, Susan. Sometimes I think that we are on the same wavelength. And a stink bug is two words, which means it's a true bug. You're right, a ladybird isn't a bird. But it is a beetle, so we separate that. Nope. All right, so here is something that I was looking for. I'll tell you what I was looking for and that I didn't find it. So I thought that possibly if I looked at the Dobsonfly from the side as a lateral view of our Dobsonfly, I might be able to show you the differentiation between the front wing and the hind wing. But there is this really nifty, I don't know what the name of this vein would be called. I want to call it the subcosta because this would be the costa, but I'm not sure what we would call this vein right here. But this vein right here is on the front wing, but it not only engages our front wing here, it's this vein here. And it's connected. It looks like this is like our leading flight edge is what I would probably call it, is right here. That's when our wings open up. This is going to be pretty much in the front. But if you look down here, the wing kind of bends at almost a complete 90-degree angle, especially up here in the front. It's pretty much bent like this. But then as you go out towards the edge, the wing starts flattening out. And this region right here gets very, very thin until the wing is flat. All right, so this is one of those things that kind of messes with your head when you're sketching too, because when we're looking at these angles, these hard solid lines right here on our edges are actually this vein up here on the top, this one that folds down. And then it kind of is gonna, so I was thinking we're gonna have to fix this really quick because that folds down, but then eventually you can see it on the top. We're not going to play with that. Not today. Maybe another time. But for those of you, you can, that's your description. And, fun thing, there's a white spot in the center of every single one of those cells. Back my brain is satisfied. You're funny, April. I hope you stick around and overpack your brain. But some species of moth prove me wrong and go the other way. Hummingbirds. Hummingbird moths. Yeah, there are white spots in every single one of the cells. That's one of our characteristics for Dobsonflies, if you're looking at it. Because, all right, so I mentioned that Dobsonflies have a filiform or a straight antenna, and that fish flies have a feathery antenna. We would call that a feathery antenna. And, well, there is a species of fish fly that has straight antenna like a Dobsonfly, but it doesn't have those white spots in the cells. So between those two characteristics, where you have long straight antenna and those white spots in the cells, then you can say, I definitely have a Dobsonfly. If you just see these straight antenna and there are no white spots in the cell, it could be a spring fish fly. Alright, let's see how well I can sketch some of these wing veins. Now, a lot of these veins are going to be angled kind of down and towards the center. So we start with, I like to start on an edge. So I'm going to go ahead and start with this guy. And then this one that forks so nicely and comes around. And then we have another one. Let's see, I need to click off of that. That comes up and around. And then it's going to fork too. Oh, man. So this is how I'm going to get those side in. I'm going to take this angle from here, and I'm just going to angle off this piece right here, and then I'm going to break our, like this, on both sides. Ideally, evenly. That's actually really nice looking. Okay, cool. You always overpack. I love it. Do we use words like hirsute or pinnate in entomology? I have not heard the word I have not heard the word hirsute used, although I know that that's a plant word that means hairy, right? We normally use cetos in entomology for hairy. Now, pinnate, I feel like I've heard the word pinnate used in entomology, but I think it was completely different than the way plant people use it. Nope. Alright, I just learned a new phrase. Let me look it up really quick so that I know what we are looking at. Pinnate leaf mimesis. which means that there was a lacewing that would mimic a pinnate leaf. And so they call it pinnate leaf mimesis. But no, we don't generally use the word pinnate either. I just looked it up to see if there was anything that Dr. Google could think of that I couldn't. But I wasn't seeing anything. So no, we don't use that word either. But I can show you that a lot of these veins are kind of just angling down and towards the center, especially when you get to the bottom of the wing vein. You can see right here in this region, there are also more than one spot per cell now. If you look at those cells, some of those have a double spot. And then if we get all the way to the bottom, you can see that texturing continues, but the cells get smaller and smaller and smaller. So when we are sketching these guys, just make sure that as you are getting closer, maybe at the bottom third of your wing, you start making those kind of smaller and smaller and smaller until they get to be tiny at the end. And once you've gotten all of these veins coming off the center, you can go ahead and give them our cross veins in here. Now keep in mind that the way I'm doing it, you do not get an exact replica of what the insect looks like. You just get the overall feel of what the wings look like. And to me, in these sketches, that's what matters. I don't feel like I need every single wing venation, as long as I have the overall feel of what the insect is and it looked like. I take, some artists, what do we call that? Like artist choice, essentially. Artistic license. That's what the phrase I was going for. I take a little bit of an artistic license and I just give it very similar texturing rather than counting and spending a lot of time. Aha! And then, if you wanted to get really fancy, you can do the exact same thing on the other side. There's a part of me, I think that it's going to look so much better if I just go ahead and get it done, so. But pinnate is the way that the wing veins, or the veins are on a leaf. And it would be kind of interesting to give words like that to the wing veins, especially when they are like this and they're all coming off of one stalk. Don't you suppose you could zoom out a little? I have a hard time understanding how much of the wing we are seeing. Trying. This is as far zoomed out as I can get because the bug is so big. And so we've got two places. I can hold it like that and I can hold it like that. And it makes me sad because I want to be able to show you like the entire guy underneath a detailed microscope. But I just don't have the capability. It's a big specimen. You gotta hit it with a little beige paint so you can draw the dots. That's a really good idea. Does this help at all, looking at it this way? So let's see. We have this portion of our wing here where you have all of the forks. It's up here closer to the top. And then if we just shift this down once to right about there, that's about halfway through. And you've got... It's widening a little bit. You can see all of those individual square cells on the edges now because the wings have flattened out just a little bit. And then if we continue past, I think that I can, essentially, the wings take three, maybe even more than 3 microscope views to get through at its furthest away point. Okay, good. I'm happy you got it now. Admittedly, that's fine. It's great. Alright, so I'm going to darken some of these veins that I had sketched out in here. They are not perfect, but they are... They exist. Right. This sketch really did need the other side. I do want to clean some of these lines up a little bit. Yay! Alright, so we have a body. We have a head, we have the pronotum, we have the wings all taken care of. Something that we really haven't looked at yet are the legs. Dobsonflies have 6 walking legs. They are pretty much basic insect legs. You will have seen legs like this over and over and over with me if you've been sketching regularly for almost a year now, ladies and gentlemen. We've been doing this every Thursday for almost a year. Right? Maybe I started teaching virtually in December. I don't think I started live streaming until a little bit later, maybe. Alright, so you probably could guess, but right about... Come on, Mr. Terry. Here. This segment right here, that's our femur. This one right here is our tibia. And these are our tarsal segments. We have 1, 2, 3, 4, 5 tarsal segments and 2 tarsal claws down there at the end. Now this left leg is pointed kind of funny. That's not how these legs normally look. I think the right leg, yeah, This right leg is more realistically positioned, so we're going to focus on this one instead. Because the femur is going to come up, the tibia is going to go down, and then the tarsi are going to go out. So I'm going to be sketching my legs pretty much exactly how you are seeing this Dobsonfly underneath the microscope. This is the western Dobsonfly, not the eastern Dobsonfly. And it has Texanus as its epithet because it was first described in Texas. All right. Our legs come off of the pronotum, but even though they come off of the pronotum, they like to come off of the back of the pronotum, just like the wings come off of the back of the pronotum. So our femur comes up. And our tibia goes out. And then our tarsal segments are going to come this way, and for me, they're going to be crossing underneath the antenna. Did I say 5 tarsal segments when we were zoomed in? You've never seen them in Washington. Are you too far north? I have not done a whole lot of collecting in Washington. I've been there, but I've not done a whole lot of collecting. So let me go ahead and look up your state and see if you guys have them in Washington. I thought that you would, because you guys have a lot of fresh water. All right, so you have 1 species. Oh, it's cool. Oh, your species is awesome. Whoa, it has funny antenna. I can hear Jeff yelling upstairs, so it sounds like the Phillies might be winning. So, there is a species in Washington. It's called Dismocohermes disjunctus. And it makes me laugh that Hermes is in its name. Maybe it flies too close to the sun. You know, what's funny is they probably come to the light. They named him after Hermes. All right, so you do have a species of a Dobsonfly in Washington. Its name is, oops, that didn't work. We're going to have to try that again. Its name is Dismocohermes disjunctus. And it does have those long filiform antennae. It's got the 4 wings. It looks like it may not have as huge of mandibles as some other Dobsonflies, so you may be looking at something that has some shorter mandibles, but keep in mind that the insects with the shorter mandibles are actually going to bite harder because they have that, that muscular strength. Think about the difference between using 12-inch forceps and like 3-inch forceps. So when you have really long forceps and you try to pinch something with it, it might not be too hard. But if you have 3-inch forceps and you pinch yourself, that could actually hurt. And so that's going to be your big difference. These guys with the big mandibles, they don't really hurt too much. Oh, you haven't found one at any of your sites. I mean, they did look pretty big. So, April, I would go ahead. Hellgrammites are known for having very, very specific microhabitats. Not really like, yes, you're going to find them all over the water. Like, you know, when you go out and you find stoneflies and mayflies and caddisflies, especially caddisflies. It doesn't matter if you're sweeping in leaf litter or if you're sweeping in rocks or other places. You're going to find caddisflies and stoneflies and mayflies and those types of things. Dobsonflies, hellgrammites are a little bit trickier to find just because you need to know their exact like little microhabitat within the water column, within the water body. And now, with your genus, with your species, I'm not sure where exactly that is. So I would love to be able to help you with that, but I can't. I'm not sure. I can tell you that the Dobsonflies in Michigan frequent a couple of places. I believe that there are 3 genera in Michigan. One of them really likes to live under large rocks within riffle environments. And that's because they have these gills that they need to breathe through, and they need the high oxygen content to be able to exist and breathe and move and thrive. And so there are some hellgrammites that will specifically go into and hang out underneath rocks within riffle environments. And you have to actually pick up the rocks and flip them over, because even if you're kicking around, a lot of times the hellgrammites can really like hold on to the rocks, so you kind of have to pick them off of the rocks. There's another genus of hellgrammite that specifically can be found in rotting logs that have fallen into the water. And then you have to find a rotting log that looks like the bark is kind of peeling away a little bit, and you start ripping apart this log in the water, and you can find the little hellgrammites in there, and that's another genus. The third genus, I don't remember exactly where its microhabitat was, but it had a unique one that was different from the other 2. And so you might have to do a little bit of searching before you find your first one in the wild. 1, 2, 3, 4, 5. So it looks like 1 is our largest segment, 2 kind of is half of that, and then 3 and 4 are little triangular segments, and then the 5th one is nice and long and ends with 2 claws. I was thinking about this recently. Entomologists haven't come up with a name for the different shapes of tarsal segments, and I feel like there are very distinct tarsal segment shapes. After sketching them so regularly, you kind of have the rectangle, where they're just all rectangular all the way down. You have the ice cream cone, where they look like they are ice cream cones that kind of could be stacked. You have the heart shape, where you have like the 2 tarsal these 2 kind of pads, and the segment comes out from in between. And then you have a water droplet shape that's narrow in the top and rounded at the end. And most of the times, the last segment is this like water droplet shape, so that they can have the 2 tarsal claws off the end. And it's funny because I've noticed this. You know, you've got these 4 kind of very specific different types and different shapes of tarsal segments. And entomologists are really good for naming every little thing, including the hairs on caterpillars. So, why aren't those named yet? If your environment is mucky and slow moving, it probably is not enough oxygen. They really like fast moving water because they don't have very efficient gills, and so they need to live in water that has lots of oxygen so that they can breathe. But if you have stoneflies, if you're finding stoneflies in your water body, and not the predatory stoneflies, the stoneflies that are like the sensitive species, if you have those, you should have hellgrammites. question. Wait a minute. Quick, draw some add some Dobsonflies to your sketches. Yeah, so that's funny. Yes, they're found in riffles. Does E. coli affect which insects will appear in your stream? I'm not sure. Let me look it up. I was hoping that it might say something about E. coli in the back of this book, so we're going to scroll through this a little bit and see what they say. They don't say anything. Darn you, Mr. Book! You're supposed to cover everything! I have not read this entire thing all the way through, but I was thinking that if anybody had information on E. coli, it would be in this book. E. coli and how it affected the insect populations in aquatic habitats. Nope. Unfortunately, I don't have an answer for you. So I know that, so this is a fun little book here. It's the protocols for, it's the United States EPA's protocols for bioassessing rivers and streams, and it covers insects, fish, and periphyton, and it has all types of really cool stuff in here, like, it has all of, like, many species, scientific names of everybody, and then their tolerance values, not only whether they're tolerant or not, but how tolerant they are. It gives them actual numbered values. It also tells you what functional feeding group that specific species is in, and what habitat, or if they have any special types of behaviors that they use. It also gives you things like this sampling data sheets that the government uses. So this is a fish sampling data sheet, but they have the insect sampling ones in here too. There we go, the macroinvertebrate field data sheets. So this is a really cool book from the EPA that gives you everything that you need for bioassessing your streams and rivers. We can name the leg shape segments. Sounds like a plan. Alright, so we have this femur here. Our tibia is going to be coming down. I'm going to try not to let it interact with this antenna because I would rather not have to worry about that. So I'm going to bring the tibia down like in this direction. Let's see. So we've got a tibia here, and we do have a little itty-bitty tibial spur down here closing in on towards the body. You still have 1, 2, 3, 4, 5 tarsal segments. I would say the first one is a long rectangle. The second one is a rectangle about half of that size. Then you have 2 triangular segments, the ice cream cone segments. And then you have the water droplet one with 2 tarsal claws. Took me 6 years to find stoneflies. I saw adults but no babes. I only found them in a spring. I bet that's where the hellgrammites will be. Yes! A spring! That sounds like the perfect place for our hellgrammites. Yeah, I mean, that is, admittedly, like a little one, that was kind of one of my dream jobs, you know. I was like, you know, considering all of the things I could do as an entomologist, and one of the things that I always came back to was working for the government and, like, doing bioassessments of rivers and streams. I started doing that as, like, I started volunteering at stonefly searches and aquatic biomonitoring for the Rouge River in Michigan when I was like, I don't know, 9 or 10. And then by the age of 13, I was leading my own groups down to the rivers, and we were collecting and stuff as part of that nonprofit. They made my mom, they were like, she can lead groups as long as your mother goes with you. And so me and my mom were a team, and she would wake up early, and we would go collecting bugs together. It was awesome. So I'm just trying to estimate where this hind leg is coming out from. Admittedly, you're not going to see the hind leg regularly when they're walking. You're going to see the front, you're going to see the middle, but a lot of times the hind legs are covered by the wings. And you can see here our hind legs are very much hidden. You can really only see these little tarsal claws pointing out at the end. And I feel like if I just put a couple of toes back here, it would look kind of funny. So I was trying to come up with, maybe I'll just do a little, like maybe this is the end of the tibia or something, and then add the tarsal segments. But maybe a little bit further down? I'm not sure. They didn't look good there. Are there any insects that only show up in heavily polluted waters? Yes. The insects that I think of, like, when you say heavily infested waters, the first insect that I think of is a rat-tailed maggot. All right, rat-tailed maggots, I think, pretty much only live in, like, absolutely fetid, gross, disgusting water. And they are... I've decided I'm not drawing the hind leg, by the way. I think that it will look odd, plus the hind leg is hidden underneath the wings. So, I'm happy with my sketch. I'm probably going to add these left legs, but I'm going to chat with you guys for a minute. Yes, rat-tailed maggots. If you've never seen one of those, I might have one in my aquatics book. They are the immature form of a fly, a flower fly? Hoverflies. So, if you've ever seen flower flies or hoverflies, where they've got those beautiful black and yellow stripes and they look like bees, but they have those really short antennae and you know they're a fly, but they look like a bee, those are hoverflies. And when those are immatures, when those are maggots, they're called rat-tailed maggots. And they look like a maggot with a tail. There's dipterans. Alright. Oh, these are my favorite dipteran. I'm going to show them to you, even though this isn't what we were talking about. Because I just saw it. Here, let's go on a little aquatics rant for a moment. So, these are one of my absolute favorite aquatic dipteran, And these are called Blephoroceridae. And Blephoroceridae are not only have a very unique environment, but they have a fun name, Blephoroceridae. And this is what they look like on the dorsal, the top, and this is what they look like on the bottom. And these maggots, they live on the stones in waterfalls. And I have not collected one yet, but I will one day find a waterfall that I can get to the base of and collect these guys. Now, you see these little circles on the bottom of them? Those are actually little suction cups. And every single segment of this maggot has a suction cup with little hairs that are also little suction cups. And they suction themselves to waterfalls. All right. If you were around for my Tarot Tuesdays in October, this is the insect that I chose for the devil. Oh, Susan, you recognize the devil! Yes, that is, when we're talking about rat-tailed maggot, it is flower fly separated. Yeah, so those are Blephorocerids. Now let me go find us some rat-tailed maggots so that we can... Now that's a mosquito. There's some midges. Some more midges. Serpents. Dolichopodids, those guys are fun. There we are. I believe this one. Yep. That is a rat-tailed maggot. And at the very, 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 very end of this really long tail, that's where the spiracle is. And so it looks like they're calling this a respiration tube. And so it's essentially a snorkel. They hang upside down, and because they live in absolutely filthy, disgusting water, they can't breathe underwater. So they have to hang from this tube as they are breathing. Yeah, he does have like a water, yeah, a water bear-like face. It always comes back to butts, and water bears are not real bears. I love that. I hadn't considered the water bears before. So it's not even just insects. Maybe it's just something that the English language does. I think that is true of most insects, and that's something that I'm always telling my students, is that, you know, you may be scared of insects now, or you may be even, like, hesitant to approach insects now, but as you hang out with me, as you learn more and more about insects, as you learn about things, they become less and less scary. And so, trying to teach students about insects and about things that they may find scary, it's going to help them in the long run, maybe not be as afraid of insects. Oh, hummingbirds are all one word, and they're real birds. Maybe they're not. Are hummingbirds real birds? Or maybe they don't just, or maybe they don't really hum. That's true. Jerusalem crickets are not in the true cricket family. They are kind of like their own type of cricket. They're a different type. Cricket is generally the word used for Grillidae, the family. Whereas like like a Jerusalem cricket is in a different family. And I think that the reason that they're called Jerusalem crickets, because I looked into this one time because I was curious. They're not from Jerusalem, so why are they called Jerusalem crickets? And I read that back in the day, a long, long time ago, Jerusalem was something you used to, like, yell in, like, when you were startled. Like, it was essentially, like, their phrase as, oh my goodness! You know, it was like, Jerusalem! I don't know. I guess that's something that I read. I would probably want to hear it from, like, somebody who knows better, because I just found that information on the internet. But, it was said that, like, they might be called Jerusalem crickets because they startled people and they scared people so much that they would say, Jerusalem! And then they just called them Jerusalem crickets. How funny is that? Jerusalem was like yelling Jiminy Cricket. Yeah, kind of like that. I love this book. Oh, I wonder if there might even be a, look at the deuterophlebotomy. All right, so here's like a real life picture of the blepharosaurids. And here's another, let's look at it. This guy is just fun shaped. Look at how fun shaped he is. And he's got little suction cups on the end of all of those phalanges. He's in the family Deuterophlebiidae, and he's another one of those aquatic insects that I've never collected. I was going to see if there was a real image of a rat-tailed maggot in the back of this, in the colors images. There it is. Right here. That's what they look like if you were going to take a picture of them in real life. He looks like a cartoon drawing of a fish skeleton. I'd have to agree about that. So here's one insect that I've always found really fascinating. We're going to have to sketch him one day. He's in alcohol, so you didn't see him in... all the aquatics are actually in alcohol. They're not pinned. This guy is called a water penny, and they're super duper duper flat, and their body is right up against the rock. And if you flip them over, they do have legs, but all you can see from the top are these like wide scales. And they're a lot of fun. I first collected them about a year and a half ago. I found them on some rocks, and I was really, really excited. And I think they're right here. Do you want to see one in real life? I can throw one under the microscope for us. Are they related to roly-polies? They look like it, but no. They are nowhere close to roly-polies. They are actually a type of beetle. So this is what he looks like from the bottom. Look at his little face. All right. So this is not an entire book of flies. This is a book called The Aquatic Insects of North America, and I was just going through the chapters that were about flies, because those were the guys that we were talking about. But if you were looking for an aquatic insects book for North America, it's this one. This is like The the aquatic insect Bible, essentially. The guys who wrote this book are absolutely amazing. There's a picture of them back here. I took a class with all three of them once, and they're all from Michigan State, which is where I went. So so I got to meet them all and hang out with them, and they're really good guys. It's like the lady made of skin. Oh, I like the one that got stretched. Oh. All right, so I actually have to, I'm going to refocus my microscope down a little bit. It's got to be closer. Here we go. So if we look all the way up here, this is where the head is. And I don't know if I've ever actually zoomed in on the head of one of these guys. So I was curious because it almost looks like he's got a little funny face. Look at his face. Has the aquatic insects book too. Very good. Yeah, if you're spending any time in aquatics, I definitely recommend it, especially if you are working with especially if you are comfortable with keying things out. The keys in that book are great. When I started sketching and doing line drawings, I took inspiration from some of the line drawings in the Aquatics Insects of North America book because their sketches were so simple, just very simple lines, but they told you everything that you needed to know to get yourself to the identification, which is what matters in a sketch for a key. Sometimes people add too much to their sketches, and then it's hard to tell exactly which characteristic they're referring to. So check this out. It looks like he's covered in fuzz down here, but those are actually gills. So all of those little hairs here, that's actually how my water penny breathes. It looks so distressed, I know. They are bushy gills. Alright, and I believe there may have been one or two of these guys that was actually so big that I thought that they might have babies, but I don't see anything here. So. He looks so cute. Yeah, so that's that. So I have never seen an adult water penny, but you are right. This is the immature form. So it's gonna grow up into a round brown or black beetle that you can find in the water. I've never found an adult water penny, and so I might want to actually go back to where I found this one, and see if I can find adults at that same location. He looks like he's got, so from this distance, he looks like he has two eyes here and here, a little face, and really long, like, you know the long mustaches? That's what he reminds me of. He looks like he's got a really long mustache. And horns. The adult beetles will have wings. This is the grub. So this is the immature stage, and it does not have wings. While I am answering questions, I feel like I would want to finish the other side of my legs. So I'm going to finish the other side of my legs really quick while I'm answering your questions. So go ahead and if you have any final questions, you can go ahead and shoot them at me, whether they are about Dobsonflies or if they are about aquatic collecting. That is definitely something that is a passion of mine. One day, I don't know how many of you guys, I guess I can ask, how many of you really enjoy math? Like, if I was going to, we could really dive into, like, aquatic ratios, and we could get into the math behind that, how many different insects with their sensitivity numbers, and throwing them into calculations to determine, like, percentage light, percentage of, particulate organic material in the water, that type of stuff you can actually determine based on the insects that you're finding. And so we could, like, make up some pretend numbers and then run calculations. And I'm not sure if that would be of interest to anybody. Oh, look at that! Okay. So do you guys like math in general? Because there's two very heavy math topics in entomology that I can think of off the top of my head. The first one is aquatic biomonitoring, because you can get really powerful. You can get, like, really strong into the ratios and stuff. And the other really strong kind of math-based entomology is we could dive into forensic entomology and determining time of death using equations and identification of maggots and using, like, degree days and temperature to determine when their eggs were laid, that type of thing, like running life tables back. That's also fairly math-heavy. Anything that would help with your restoration work. Perfect. So, macros, here we come. I love aquatics, so we can dive into that someday. You might want to give me a week or two to freshen up on some of my math. I have all of my notes in my memory, and I feel like off the top of my head I could teach a good amount of it, but I want to make sure that if I'm sharing it with you guys to help with your restoration projects and other things, that I want to make sure that they are all fresh in my head. So I'll go through my notes, make sure I'm aware of the ratios, and see if there's anything new out there that we could use too. So that sounds like a lot of fun. And I spent enough time that I actually got the rest of my legs finished on my Dobsonfly. So there we go. It is just a little bit after midnight, and I'm thinking that it's about time for me to head off. So if we don't have any final questions about anything here, I'm glad that we went on a mini rant about aquatics. I do love them. And I guess, you know what, we drew a Dobsonfly, but I never showed you a picture of a Hellgrammite. And I was thinking I didn't have any pictures of my own of Hellgrammites, but I don't think that anybody cares if I share images from books that I own. So I believe I will be able to find a Hellgrammite picture in here so that you can at least see one if you've never seen one in the past. Oh, he has Tetryggids in here. That's cool. Pleiades. There we go. So, we've got this little friend here. This is one type of Hellgrammite. He's hanging out on the bottom with some of his rocks, And this guy here prefers to hang out upside down, it looks like on a steak. On a steak. So, yep. Corydalids. In the freshwater invertebrate zoology class I took a while ago, I got to do some collecting, identifying, and counting for a local stream health project. It was informative and very fun. Oh, I'm so happy that you got to do that, Ramada. Yeah, it's something that I've always loved. And I started doing aquatic biomonitoring as a volunteer, like before I was 10. And then I was a part of that program until I went off to college. So I was a part of it for probably about 8-9 years, something like that. And I would really like to do more biomonitoring. I think that here, the Delaware River, the Friends of the Delaware, could really use some biomonitoring in Philly. I'm a mathematician, but I'm a topologist, so mostly I'm working with numbers and equations. Cool. What are the spikes coming off? I imagine them to be gills, but they don't look gilly. They are not gills. Let me show you those one more time. Alright, so we've got these. I'm double checking with my notes really quick because I believe, yeah. It depends on, this is a funny one. It depends on actually what genus you're looking at as to how these, Dobsonflies breathe. So we call these things coming off of the edge, we call them lateral filaments. All right, and these lateral filaments, they are not used to breathe, but honestly, I'm not sure what they are exactly used for. They seem to be mostly useless, just kind of there. Personally, I think it makes them look scary. They are a predator in the aquatic world, so they're big and scary, and they are there to eat you. Now, this species, or genus, the genus Corydallis, they have gill tufts. So they have armpit hair. They have gill tufts here at the base of every single one of their lateral filaments. So I didn't take these pictures. I stole these ones off of the internet when I was doing school. And so these are these little gill tufts here. Now, if we were looking at Chauleotes, they actually breathe, they don't breathe through gills like these guys do. They actually have a siphon. Asymmetrical spiracular siphons. So you can see there's two butt snorkels. There's a short butt snorkel and a long butt snorkel. And the fact that they are asymmetrical will help you identify this one all the way down to genus. And this last one here is Nicronia, and they have spiracular siphons, but it doesn't go past the lateral filament, so they're short. All right, so thank you. Yes, double butt snorkels, April. All right, I do want to head off, so I super appreciate everybody hanging out with me today, sketching a Dobsonfly, looking at our Hellgrammites, talking about aquatic insects. I definitely look forward to doing numbers, and we can do that next week if we would like. So, good night, everybody. Feel free to join, feel free to share the link in the description box with any students ages 5 to 8, 9 to 12, because I teach students on Zoom through a platform called OutSchool. If you are not already, please subscribe to my YouTube channel. If you are not subscribed, you can't chat with us. So join join the chat box and make sure you subscribe. This down here is just a PayPal link. It's to if you would like to donate to Insectopia to help keep my collection going. That is there. You also have there's also a link in the description box below if the QR code doesn't work for you. That is obviously totally optional, but always super, super appreciated. Thank you for all of you who regularly donate that. It means the absolute world to me. Right here. That's my tag on both Facebook and Instagram. So if you were looking for me and you type @Insectopia and you can't find me, that's because you need to add the 2015 at the end. I'm at Insectopia 2015 on both Facebook and Instagram. You're welcome. I mean, I will go on bug rants with you guys all the time. Like, just ask and I will answer, and we can go on so many bug rants. It's my favorite thing to do. Drawing invertebrates is always so fun. I have to agree. It is. I mean, looking at the legs and the antenna, and I think also when you're going through and you're looking at an animal that's unique and you've never seen before, and then not only have you not seen it, but now you're seeing it under a microscope, and you get to see what it looks like and what it does and why it does it that way, and then you realize that those insects are just a very, very small population of a huge number of insects out there on the planet, and you realize, oh my goodness, there are millions of these things out there. And it took Trisha 3 hours just to go through her little itty-bitty collection. There are some wonderfully beautiful insect collections out there, and one day mine will be larger. It's growing. All right, have a wonderful rest of your week. I look forward to seeing you on Sunday at 4 p.m. Eastern or next Thursday at 10 p.m. And stay buggy. Have a great night.